Have you ever stopped to think about the world around you? I mean, really think about it? Consider that simple cup of coffee you might be holding right now. It seems ordinary, doesn't it? But inside that warm mug, a symphony of chemistry is playing out. Or what about that onion sitting on your kitchen counter? Slice into it and it unleashes a chemical defense that can bring a tear to your eye. And who can forget the heart-pounding thrill of a roller coaster? That stomach in your throat feeling is all thanks to the fundamental laws of physics. Science isn't just something that happens in a laboratory with bubbling beakers and complicated equations. It is happening all around us, all the time, in the most ordinary of places. Every single day, you are an unwitting participant in countless scientific experiments. When you toast a piece of bread, you're witnessing a chemical reaction called the Maillard reaction, which gives it that delicious brown color and toasty flavor. When you see a rainbow after a storm, you're observing the physics of light refraction and reflection. Let's start our scientific journey with one of the world's most popular rituals, making a cup of coffee. It seems so simple, right? You just add hot water to ground up coffee beans. But oh, there is so much more going on. The magic begins with heating the water. When you turn on your electric kettle or place a pot on the stove, you are initiating a process called heat transfer. Energy from the heating element or the flame is transferred to the water molecules, causing them to vibrate faster and faster. As they gain energy, they move more freely, bumping into each other with increasing vigor. This increased molecular motion is what we perceive as temperature rising. Once the water is hot enough, ideally between 195 and 205 degrees Fahrenheit, about 90 to 96 degrees Celsius, it's ready to work its magic on the coffee grounds. If the water is too cold, it won't extract properly. Your coffee will taste weak, sour, underdeveloped. If the water is too hot, it extracts too much, including bitter, unpleasant compounds. Result, a harsh, burnt taste. It's a delicate balancing act, a morning science experiment. As hot water saturates the grounds, you get that rich coffee aroma. That smell is the first sign of chemical reactions to come. The aroma comes from volatile organic compounds, tiny molecules that evaporate from the grounds and float to your nose. Think of them as the opening act. These aromatic compounds preview the flavors and signal extraction is underway. Water acts as a solvent, dissolving hundreds of chemical compounds from the grounds. This isn't just hot bean water. It's a complex chemical solution. Water pulls out acids, oils, sugars, other solids. The fineness of the grind, the water temperature, and the contact time all determine which compounds are extracted and in what amounts. Now that our water is at the perfect temperature and the initial aromas are filling the air, let's dive deeper into the main event, the extraction process. This is where the true character of the coffee is born. Imagine each tiny particle of ground coffee as a microscopic treasure chest, packed with all the makings of a delicious beverage. The hot water is the key that unlocks these chests. As the water flows through the grounds, it acts as a powerful solvent, dissolving and carrying away a huge variety of chemical compounds. This isn't just a simple washing process. It's a carefully timed chemical heist, where the goal is to steal the good stuff and leave the bad stuff behind. The first compounds to be extracted are the fruit-like acids and fats. These are relatively easy for the water to dissolve and are responsible for the bright, vibrant, and sometimes citrusy notes. This is why if you brew your coffee for too short a time, it might taste sour. You've only extracted these initial acidic compounds. As the brewing continues, the water starts to dissolve the sugars. These sugars are essential for balancing the acidity and giving the coffee its sweetness and body. A well-brewed cup of coffee has a perfect harmony between the initial acidity and the sweetness that follows, creating a complex and satisfying flavor profile. If the extraction process goes on for too long, however, we start to enter the danger zone. After the acids and sugars, the water begins to extract the more bitter plant fiber compounds from deep within the coffee grounds. These compounds, like tannins, are much harder to dissolve, which is why they only come out during over-extraction. This is what leads to that classic bitter, dry, and astringent taste you get from coffee that has been left to brew for too long or was ground too finely. The goal of a perfect brew is to stop the extraction right after you've gotten all the sugars, but before these bitter compounds take over. All right, Let's move from the pleasant aroma of coffee to a much more tearful kitchen phenomenon. We've all been there. You're dicing an onion for dinner, and suddenly your eyes start to sting and water uncontrollably. You're not sad, so why are you crying? The answer lies in some fascinating and rather dramatic plant biochemistry. An onion is not just a simple vegetable, it's a master of chemical warfare. When an onion is whole and undamaged, everything inside it is perfectly fine. The compounds that will eventually make you cry are stored in separate compartments within the onion's cells, like keeping two harmless chemicals in different bottles. The trouble begins the moment your knife slices through the onion's flesh. This action ruptures the onion's cells, breaking down the walls that kept those chemicals separate. When these compartments are broken, the enzyme oleanous is released. Alinase immediately reacts with sulfur-containing compounds stored in the cells. That reaction creates a new, highly volatile and unstable substance, syn-propanethyl S-oxide. This tear-inducing sulfur compound is light enough to float up from the cutting board. The invisible syn-propanethyl S-oxide wafts up and heads straight for your eyes. Your eyes are coated in a thin layer of water called the tear film to keep them moist and protected. When the onion gas meets that moisture, it reacts again. It dissolves in your tears to form a very mild solution of sulfuric acid. From the kitchen, let's blast off to the amusement park, a lesson in physics that is anything but boring. Roller coasters are more than just thrilling rides. They are masterful demonstrations of energy motion forces, a choreographed dance between potential energy, kinetic energy, slow, clackety-clack climb up the first and tallest hill. This is the lift hill. It builds a massive amount of potential energy. Potential energy, stored energy, the energy of position. The higher you go, the more potential energy you accumulate. Gravity pulls you back down. At the very top, maximum potential energy, very little kinetic energy. For a split second, you feel like you're floating. Then gravity takes over. The train plummets down the steep drop. Transformation begins. All that stored potential energy is rapidly converted into kinetic energy. The higher the hill, the more potential energy was stored, the more kinetic is released. While energy conversions explain how a roller coaster moves, it's the forces you feel that make it so exhilarating. This is all thanks to acceleration and something called G-forces. As you go over the top of a hill, you feel lighter, even lifting out of your seat. This is negative G-force, airtime. From the chemical reactions brewing in your coffee pot, to the biochemical defenses of an onion, to the elegant physics of a roller coaster, it's clear that science is not confined to textbooks or laboratories. It is woven into the very fabric of our daily existence. Every object we touch and every action we take is governed by scientific principles. The world is a living, breathing, interactive science exhibit, and we are all participants. Understanding the science behind these everyday phenomena doesn't take the magic away. In fact, it adds a whole new layer of wonder. Think about it. Knowing why an onion makes you cry transforms a kitchen annoyance into a lesson in plant biology. Understanding potential and kinetic energy turns a roller coaster into a real-world demo of physics. These explanations enrich our experiences, connecting us to the deeper workings of the universe. It encourages us to look past the surface and ask, why? Why does bread get moldy? What makes soap work? How does a microwave heat food? Keep asking questions, stay curious, and never stop exploring the incredible science of your everyday life. Science is everywhere. Learn it, love it, live it.